So I'm coming back for my part two of the, shall I say, a general topic on engineering equations. But actually, this is also what we call as science slash engineering equations. So we have to connect the basic science equations to some basic equations also in mathematics. Okay? So just yesterday I finished the linkage or the collaboration of some mathematics topics to, to engineering equations. Sabi na nila, collaboration. Sorry. Meron sa kong kape guys. Tara kape. Okay. Okay. Actually, I didn't plan to vlog at this moment in time. This is just only, what comes on my mind because, oh my god, I need to do this. Okay, my gosh. Okay. So, parati na lang ganito, meaning, unscripted. Gosh. Kasi ang saya pag, unscripted. Meaning, hindi pinaghandaan, di ba? Kasi nandun ang challenge if you don't prepare. Because actually, this is not a formal setting of discussion or just like doing a training or a conference or any symposium or shall we say a formal gathering or an event. This is not a formal way. This is only informal. You need to say what comes to my mind. Oh, I love to vlog at this moment in time. Then I have to do this. Something like that. Okay? So, ganun ang mangyayari. Okay? So, not prepared. Okay. So, in here we will rely to the, shall we say, stock knowledge and acquired knowledge in combination to some knowledge that I researched also, okay, in online world and some references also in Wikipedia or shall we say also small glimpse on the Google search because there are times I cannot understand, I have to Google search that one. Okay, something like that. There are deep also technical terms that I cannot understand really. You have to go to the Webster dictionary sometimes or in the Google search engine. But the main accumulation of the knowledge will be more on the acquired knowledge and stack knowledge. Okay guys? Gosh. Ay nako. Hello guys, I just off my AC because it's very cold. Okay, because if the BER coming, Burr, September, October, November, I feel it's very cold already. Okay, then I don't want also to, to vlog with, too much cold. Okay, my brain cells, tissues and muscles will also shrink and compressed. Okay? It's gonna be like that, right? If you can remember also science, the more it is cold environment, the more there will be a shrinkage. What? Shrinkage. There will be a compression of your objects or whatever. It is correct. Okay? Or it is the reverse. So what I understand is gonna be like that. Okay? So let's check that later. It's the relationship between compressibility and expansion. So, if you can really remember what's going on, if we talk about science, it's really be happening if you try to increase the temperature, the objects will compress or expand. But what I understand now on the spot, okay, not reviewing the principles or concept, but on the spot in a quick second. What I understand, if the temperature is very cold or less temperature, it will shrink, compressed, something like that. But I'm not really that sure. Disclaimer, correct me if I'm wrong, for now, unless I could review also some. Wait for a while. We need to check that out. The relationship between compressibility and expansion, if we try to adjust the operating parameters or conditions, the temperature and pressure. It's gonna be like that, right? It's gonna be always operating conditions or parameters which are specifically the temperature and the pressure. So in here, with regards to temperature, because it also implies how cold and how hot really the environment really is inside my room. It's gonna be like that. Because I noticed that also when this is only a relation, not technically proven to be correct, based on my inference. Wow, inference. Okay, inference meaning a higher degree of observation. Okay, observation is plain observation, only meaning using your eyes, ears, nose, smell of touch, smell of hearing. But inference, you observe also at the same time, you use your brain to balance how logical it is, how reliable it is, or how it is accepted to the basis of science. Something that's inference. Meaning to say this is more profound in comparison to observation, plain observation. And inference also is one of the technique higher degree than observation if you do a scientific research, right? So most of our scientists do an observations. So observations are not limited. Okay, you can gather data and later you can reject that somewhere along the way if those data will not be used to increase the validity of your scientific research. How reliable is that? But for inference, it's more okay. It would be for a quickly studied at this moment in time or whatever, like that, right? Get the point? Like this, going back to what I'm talking to you. When I'm singing, okay, a song, okay, I'll observe that if I will never off the AC, I cannot belt out the high notes somewhere on the bridge, something like that. So mean to say that the muscles and tissues in my vocal larynx will be shrinking or compressed. So, in order to expand your muscles and tissues in your vocal larynx, then you have to develop a little bit increase in the temperature. So I must off the AC to equalize the temperature gradient inside the room. Then I can expand my voice to higher extent. Charot. Okay, to let's say to reach the higher notes, something like that. So that's what I observed when I was singing. That's why when I do my FB live streaming, I'll just off the AC. Really, I don't want the AC. That's also the reason I cannot sing properly with AC, with having an AC. Though in a contrary point of view also, you need to build up oxygen molecule when you sing, right? Because during breathing, because vocal coaching ako. So when you do oh my gosh, what's happening? Ano na shallow, but na ako guys, I have to talk without the microphone. Okay, you can still hear me. So I will tell you something that in vocal coaching, or should we say a vocal lesson, okay, so if you don't have an oxygen molecule during your breathing technique, then you can not also reach the high notes. Something like that. That's why when I'm saying, I open my mouth very wide, round, and just like eating the diameter of the microphone when I shout. Something like that. Okay, that's the reason behind, because I need to develop a vocal stamina during my breathing technique in singing a song. It's not enough to sing like you open your mouth. That is a technique. Open your mouth round, okay, so that you can enunciate well the pronunciation and the diction of the message of the song, and then you can also help to reach the high notes. Okay. I don't know what's really correct. I think this is gonna be an educational guess or educated guess, right? Because sometimes also I feel itchy, something like that, especially when I'm not yet taking a bath or taking my showers. It's very hot also, and I have to on my AC sometimes like that. But for now, I'm finished my showers, so I don't need any more that AC. Okay, later if I will feel a little bit hotter, then I have to on also the AC. But at this point in time, I must off, right? And another reason also, guys, the sound of the AC will also be interfering. Wow, will be also a little bit of disturbance to the quality of the sound of my vlogging and live streaming. Really, because the AC is not very new. There's a noisy effect like that. So it's not very perfect condition, not in a perfect good condition. That's why sometimes it's noisy. So it also interferes with the quality of the sound of my vlogging and live streaming. Something like that. Okay, guys? So before we start our official vlogging and live streaming, okay? So where did we stop yesterday, guys, in our engineering equations? Where did we stop? I forgot. My gosh. I think we stopped before in the... I don't use microphone. Okay, I'll just try to make my voice loud. Okay, so that you can hear me, guys, okay? Anyway, it can still be heard, actually. But I want really, to be intensified because there's an echo. You know, the echo will make my voice louder enough during the actual output of my live streaming and vlogging. So I use microphone, something like, because sometimes my voice is weak, it's not loud like that, especially when I'm just waking up in the morning, right? Sometimes also there's a situation like that. When I wake up in the morning, then I will never take a bath directly. I will go live directly sometimes, but that is only in rare cases. Okay, but most of the times I've already eaten my breakfast, lunch, dinner, and I'm already completing my shower before I do the vloggings and live streamings, right? Okay. Any questions so far? Guys, if there is something gray part in my discussion, gray part, G-R-E-Y, meaning a little bit of confusion, then you can also comment me in the comment section and we have to polish that one because I'm not perfect. Really, I'm not perfect. Okay, it doesn't mean that you are, let's say you are a licensed engineer or whatever, your status in life professionally or whatever the status of your career path, then it looks like to be perfect all the time. Especially in my case, I don't vlog and live stream scripted and prepared. Really, I don't treat that as a challenge. That's why you can notice me when I'm in a discussion, I reach 1 hour, 2 hours because it is not planned actually. What comes on my mind, then I will be able to vlog directly. Okay, something like that. Really? Okay, sige na, masapid akong dila, di ba? So you know that. Masapid akong dila. That's the result of really not practiced, no rehearsal, not scripted type of vlogging and live streaming. Because if I do that, there's no challenge. It's just like that I already solved, and then I presented you guys how to solve it, and then I already corrected perfectly like that. And then, oh, it's correct because you're an engineer. For me, it doesn't look like challenging in my part. Di naman ibig sabihin na pinaghirapan ko yung sarili ko. It's that I want really to solve by my own without looking to the how the problems being solved by the original author of the book or the vlogger or uploader, something like that. I really want to solve by my own so that I can apply my knowledge in my education in BS chemical engineering. And also not only that, my knowledge or my stock knowledge in my, shall we say, trainings attended or my educational level in high school and elementary, something like that. Actually, guys, it's a correlation between the stock knowledge in your elementary level or grade school level acquired plus your educational level, educational knowledge acquired in your high school level, something like that, or secondary level, right? It's just the same. When we mean of high school, specifically, I'm talking here, guys, in the educational system of the Philippines. So we are using high school equivalent to secondary. And then we mean to college education, we mean that is tertiary level of education. In other parts of the world, the categories are not really the same with our educational system imposed by our political leaders in our country, especially in our CHED and our, what do you call this one? SPED? That's SPED ba yan siya? Dex ba yan siya? Nakalimutan ko. Basta sa education educational program or educational department. Okay, educational department governed by the government. Something like that, right? Saan man to siya nakalimot ko? Dex before it was changed to, uy, mga teachers, changed to, ano na siya eh? Bilisdan man to siya bagong name. Charot. In which, nakalimot akong brain cells. Charot! On the spot. Oh my gosh. So this is really an olive coffee. Okay, I choose olive coffee because the aroma is very good. Okay, the smell is very good, and compared to the Nescafe. Okay, actually, Nescafe is the standard all over the world, but I just love to buy this olive coffee because the smell is very good. Okay, I think this is only an immune to me because I always buy this to drink. Okay, that's why I use olive coffee, but it doesn't mean like that. The taste is really different compared to the Nescafe, something like that. Okay, so that's why I love olive coffee. Charot! I'm not campaigning to other coffee product. I'm not an endorser really. I'm just telling you the truth. In my part, disclaimer, not to anybody else. In my personal conviction, okay, that in my own belief that this olive coffee tastes so good and it smells very good for me, especially the aroma, okay, the smell, okay, and also I notice also when I make coffee, it's very quick to become cold compared to other months because as I told you earlier, there is a cold months, right? So when I make the coffee and suddenly after 10 to 15 minutes it become cold. Oh my goodness, what's happening? There's a heat transfer from hot to cold, right? In which that is the theory of heat transfer, the temperature gradient, the thermal equilibrium in the system and in the process. So it's gonna be like that. It should be it can be proven through the theory of heat transfer. Okay, something like in transport phenomena, unit operations pa rin at saka physical chemistry or thermodynamics, right? So thermodynamics because temperature and heat is involved. Okay? So it's gonna be like that's apply talaga siya, no? Sa akong mga discussion in my previous discussion about temperature changes, exothermic reaction, endothermic reaction, and we need to understand blah blah. Sorry. Ganon. Okay, guys. I need to introduce another equations that are very useful in the, shall we say, chemical engineering major subjects, mainly the physical chemistry, the unit operations or the unit processes, and also the, what we call this one, thermodynamics. So these are really the equations that if we talk about Cebuano language, something like that, gas-gas, og bunog na gyud siya. Just like in a singing contest, so many singers always sing this kind of song every time, and it looks like boring to the audience, to the board of the judges. The chance is those contestants will never win because that songs are always sung a couple of times in a singing competition. It looks like boring and there's nothing new. So it's gonna be like that, but it is really a basic contest piece that will be used by the amateur singers, something like that. So it's gonna be like that also here. This is very important also because these are the basic equations to be used in your higher chemical engineering subjects. What's happening? Oh my gosh. Okay, we will start with, so I love really this kind of formula, the basis of all. Okay. By the way, class, we need to understand, I'll give you a theories, okay? So that we can really understand what's going on if we apply this to the higher chemical engineering subjects, or should we say other science courses, right? I'm not really that familiar with the descriptive curriculum subjects of Bachelor of Science in Chemistry. I'm not really sure. But this said, it's pretty closer to the BS Chemical Engineering. But I don't think so, right? Because their mathematics are not engineering based. They're mathematics in BS Chemistry. So the approach is not totally the same with the chemical engineering mathematics because the approach of engineering mathematics are so structured. Structured, meaning a lot of, a lot of pasikot-sikot, and through derivation, we can obtain another equations out of that, and we need to correlate other formulas, and then we need to incorporate that there. Sorry guys, my gosh. So we can create our own mathematical formulas or equations. I don't think so because I don't have a friend that take or took up BS chemistry also. Okay, so what I know also is BS physics is related also to chemical engineering, but again, the application of mathematics, okay, is a little bit different. Okay, practical application of mathematics on the same time of technology. So these sciences, pure sciences, physics and chemistry are, they are very, very, shall we say, extensive learning and deep theories and concepts. Okay, but for us, we are not very, very go into the deeper of theories and principles because we always, link with mathematical applications, solving real complex problems. If we put ourselves to the actual scenario of being, for example, being a process engineer or being a design engineer or being a technical engineer, something like that. So, or being, shall we say, a production engineer or being a cadet engineer for the very, very first time for your experience before you will go higher in position and having an engineer positions in the industries. It starts with the cadet engineers, right? Okay, something like that. Okay, now, nagsugod na tayo. Grabe kayo pasakali, in fairness. Okay? So, ganun siya. So, mag-start ka sa law of conservation of matter, law of conservation of energy, and law of conservation of mass. Now, if we have a solid background and concept for these three laws, we can understand really what's going on in pure sciences, okay, especially in chemistry, because chemistry are dealing with changes. It could be a physical change and a chemical change, and in that also you have an adequate knowledge if it is really a physical property or a chemical property of that substances. Then through that, if you have knowledge of that, then you can also troubleshoot how the substance can behave in a chemical reaction. Okay, so something like that. So in that, we need to understand the law of conservation of matter. Okay, again, review. What is a matter? Okay, so ato dyan siyang ipasok sa atong brain cells, the definition of a matter. Okay, so I memorized this also when I was in elementary. I think when I was in grade 4 or grade 5. Okay, because I love science too much. I memorized this and Baden in high school also. And then, na-inject na siya sa akong brain cells up to now. Okay, so what is the matter? Anybody? Any high school students in front of me or even a first year college, second year college, or elementary grade 6 student? Okay, but the standard schools all over the world, especially private schools, they have a very, very, what do you call this one? Advanced science nowadays. They can really understand what is really a chemistry, what is really a physics, what is really a biology, what is really an earth science, what is really a astronomy. Okay, astronomy, I think it's a branch of science that deals with the study of the galaxy, the Milky Way, the universe, something like that, right? That is astronomy, if I'm not mistaken. Okay, and the earth science, studying about the earth's surface, including the land, the water, the sea, and the atmosphere. Ganon, mga ganon siya, di ba? Mga mesosphere, lithosphere, hydrosphere, biosphere, ganon. Mga leveling of the atmospheric regions in the atmosphere, something like that. Okay, so earth science siya, right? So basically the environmental chemistry is under only in the earth science, if I'm not mistaken. And then also the metallurgy, okay, is a branch of science, those who study of the variation and the composition of metals or elements. So metallurgy, also is under mining engineering, and also this mining engineering and metallurgy are under also in the environment, in which this is also under in studying of earth science. So meaning to say earth science is a general, and then this metallurgy, okay, study, or metallurgical study, and the mining engineering study, or the geology also. That's why we have geologists, the study of, you know, the movements and the behavior of the underground soil, water, the responsible for the, you know, the study of seismological effect of our Earth's crust. Sorry, this is not my masterpiece, but because I read, I can understand a little bit. So seismology is a study of, you know, the earthquake, the eruption of the Earth's crust, something like that. So seismology, and related to, you know, volcanic eruption. So undergat po niya siya sa earth science in general. Okay, so that's still also pure science. A lot naman talaga ang pure science, right? So it's very interesting. It's very broad, right? Okay, now we will go back to the equations. Okay, ganon. Oh, sorry. A law of conservation of matter. Matter is anything that occupies space and has mass or weight. Okay, these are solid, liquid, and gas. Something like that. Okay, so the molecules of a solid are very compact to each other. The molecules of a liquid is a little bit far away with each other, but the gas molecules are very, very far apart with each other. So we can say it is not difficult to compress a gas compared to the liquid and the solid. Okay, because it's already separated the molecules, and you have still to apply a lot of kinetic energy and temperature to compress the solid and the liquid molecules, right? And it's very clear. So we can also understand the principles behind, right? The temperature, the kinetic energy, the number of moles, the pressure, and everything. I think this moment will not be enough if I will tackle everything regarding the pure science. Really, okay? So how many years, right? 5 years, 4 years. It took 6 plus 4, 10 plus 5. 6 plus 4 plus 5. 15 years plus 1. 16 years all in all. Okay? So in my part, 16 years all in all. In my elementary level is grade 1 to grade 6. 6 years. Okay, high school or secondary level, 4 years. First year high school to fourth. Because before, it's not like at present in the Philippine educational system, they are now having the K7 program, ganun siya, in which they have grade 7, grade 8, 9, 10, 11. It's not that before. They have changed already. Okay, so like that, so 10 na siya. Plus 5 years in chemical engineering, 15. Plus a lot of preparation prior to the board examination. Let us say it runs to 1 year. This is gonna be 16 years in preparation before exposing myself to the actual, you know, to actual field in my line of specialization. Okay, something like this, a chemical engineer, but it not took me a long time to you know, experience being a chemical engineer. I think it runs only to 3 years maximum. Wait, I should remember. Okay, 3 to 4 years maximum only. I am exposing myself being a chemical engineer. So as far as I can remember, in the, you know, I work in geothermal power plant in Ormoc, Leyte. Okay, so geothermal power plant, the California Energy. So we analyzed their cooling water system, something like that, in the laboratory. And then I also work in the water treatment chemicals, analyzing the parameters of water, the quality of the water also, the boiler water, the cooling water, potable water, everything, the quality of the water, something like that. And I also experience also in the General Milling Corporation in Batangas, okay, Tabangao, Batangas. So we check lines to lines, something like that, and climbing up, you know, too much climbing. If you are really working in a chemical engineer, you have to climb to test the, for example, the exhaust gas. You have to determine the quality, the sampling, and then you have to undergo that in the laboratory to analyze what's the percentage of, you know, H2S, the, you know, a lot of gases, mga ganon sa chuba-chucho. Okay, carbon dioxide, carbon monoxide, mga ganon. Okay, a lot and a whole lot more, mga ganon, di ba? So, ang saya-saya. So, at least, oh my gosh. Really. So at least, being a chemical engineer, I already enjoyed that before going to the another field, which is the OSH, Occupational Safety and Health Engineer. So I already exposed myself to the actual scenario. Okay, and I really forgot. Really, the last is the I'm working in the Coca-Cola Bottlers Incorporated Philippines. Okay, in again, I love Ormoc talaga, no? Ormoc City. Okay, actually they don't have lift soft drink, the color yellow green, equivalent to the Mountain Dew. So the lines in Ormoc are only Coke, Royal True Orange, and then the Sprite. We have only line 3. So I act there in the QA department, okay, as a quality product engineer in the laboratory. So what my job there is to formulate the proportions of the mixtures and the components of the the soft drinks, something like that. And then okay, then after my calculation, actually we are more, not only me. After the calculation, we will pass that to the chemist in the second level, and they will be the one to have the proportion on the mixing. Meaning to say we are on the calculation part, something like that. Or you will mix this syrup to water. You're gonna mix this, you're gonna mix this CO2, okay? Because soft drinks has CO2 in the ingredients, and then you have to follow what are the amount of CO2 to be needed, something like that. So actually the syrup, I don't have to tell anything, because maybe ano, ikaso ko kay kung ano ba na siya, confidential. The formulation of Coca-Cola Bottlers Philippines Incorporated are very confidential. Okay? So something like that. So it's a form of mixture na talaga siya in which they acquire that in Atlanta, USA. Okay? Then after that, it will be delivered to our plant, and we will just get that and do a sampling if it is past the parameters before using that syrup, in which that is a combination of blah blah blah, and then also the concentrates. You know the concentrates? The concentrates are a mixture of chuba chucho, in which we don't know. Only a formulation coming from the Atlanta, USA. So we are able to mix that out. Okay? The syrup, the concentrates, and the amount of the water, the carbon dioxide, okay, and a little bit of, what do you call this one? Diluted phosphoric acid. Okay, if I'm not mistaken, correct me if I'm wrong. Because soft drinks has diluted phosphoric acid. Okay, really? I just review that one because maybe it's sulfuric, but I doubt that it's not sulfuric. Based on my memory recall, that is diluted phosphoric acid. Okay, so the soft drinks contains a little bit of phosphoric acid. Meaning to say not concentrated because diluted kasi siya. Okay, so more on solvent. So it doesn't matter at all. Dili man siya concentrated, so dili mga poison ang mga tao sa tungkol sa kataas sa acidity kay diluted man siya, diluted phosphoric acid. Okay? And our body also need phosphorus. Okay? So this phosphorus will be needed also in the production of protein inside our body. Phosphorus P. Okay? The symbol of phosphorus. So this phosphorus coming from the diluted phosphoric acid will react inside our body and then to the protein synthesis. Okay? Ganun siya. Basta, if you study the organic chemistry, you can understand what I'm talking to. Okay? Going back, may taas na dyan kung ano, yaw-yaw. Okay. So, law of conservation of matter, mauto siya. So, matter, again, i-memorize na lang siya guys, kaya mo gini siya for me. Matter can neither be created nor can be destroyed by ordinary chemical means. Okay, muna siya ang law of conservation of matter. Okay, law of conservation of mass. Okay, the amounts of or mass in the reactant should always equal to the amounts of the mass of the product in a steady state chemical reaction. That is the law of conservation of mass. So that's why we have, if you take up chemical engineering, we have stoichiometry subjects or CHE calculations because it deals with the amounts. We need to compute amounts of our substances, what will be going on in our chemical reaction. And we need to determine that stoichiometric relationship by quantity and amount, and we need to compute something like that. Okay, so that is law of conservation of mass. Okay, now the last law of conservation of energy. So, you change only the word matter, the matter, change only the word of energy. Ano siya? Energy instead of matter, right? So, law of conservation of energy naman ta. So, energy can neither be created nor can be destroyed, but, ang sumpot niya, lain na siya, but, it can be transformed to various forms of energies. Something like that. So, mo nang natay mga chemical energy, electrical energy, hydrothermal energy, geothermal energy, pneumatic energy, hydrostatic energy, acoustic energy, light energy, thermal energy, radiation energy, kinetic energy, potential energy, mechanical energy, because it was being transformed to any various of energy. So that is the law of conservation of energy, specifically, no, sapit na pugugan. Guys, specifically being discussed in the first law of thermodynamics. Okay? As you can remember, right? Change in internal energy is equals to the heat content minus the work. Am I correct? Really something. Delta U is our internal energy. It's gonna be like that. And then if you treat that as a, let's say, a diabatic process, then change in internal energy will be directly equal to the work done. It's gonna be released into the system. Okay, negative W man siya, di ba? Released. Okay? Release negative. So just okay, our Q is become zero man. If you talk about a diabatic process, guys, there's no heat loss. There's no heat exchange. Heat will be zero. That's why it is delta U is equal to negative W. Okay, meaning to say, all your internal energy applied will be converted into work that was being released to the system. I'm not really sure, release or absorb. Take muna ha, ako sige analyze. Charot! Teka muna. Work release, absorb. It's gonna be, if you release that one, so, yeah, release, negative siya, di ba? Kung i-release ni mo, negative ba ng imong system? Right? Okay? So, kung i-absorb ni mo, ma-positive ang imong system. So, it will become positive W. But kung negative W, imo siyang gi-release sa system na negative na ang imong system. Get the point? Ana man na siya, guys. System and the environment or the surrounding. Okay? So, if we mean in science or let's say in physical chemistry ba na siya, surrounding and environment, that would mean the same thing. Your environment and your surrounding. So, the system is your source system. Okay, so it's in the surrounding and environment in which your process taking place. Process, P-R-O-C-E-S-S. Then your process could either be a physical process or a chemical process. So those are coming from the system that will be trying to perform their activities in the environment or in the surrounding. So technically, the process will be occurring in the environment or in the surrounding. So if you take that in a big picture, if you have a petroleum factory or a petroleum plant, your surrounding or your environment will be the plant itself. Okay? And then your process will be the process A, process B, process D, process D. Your, flow charts where your process taking place from initial to the final, from the feed to the product side, something like that, okay? And then your system will be your, your inlet in which you feed your raw materials, okay? So that is your system. So the accumulation of the raw materials, okay? Something like that is your system. Kung imo na siyang ibuhagay dito, wala na siya sa imong system, okay? So just like our body. Okay, our system, we have an immune system, pero kung labas na siya, hindi na consider sa immune system. Okay, it's being expelled naman siya out from our body. It's gonna be releasing to the environment. Ganon. Or surrounding. Oh, so muna siya ang law of conservation of mass, law of conservation of matter, law of conservation of energy. Something like that. Get the point now? Gito na ta sa kuan, sa equation. Now guys, familiar kayo sa mga engineering nga course nga usually guys we will have to deal in the sa mga kuan siya, mga steady state equation lang gyud siya per me. Why? Because in a steady state equation, it's very simplified to understand, simple to understand compared to the unsteady state equation nga masyado kasi siyang time dependent, in which we could no longer detect the exact probability of the position and the movement of any particles and molecules at a certain time t, right? So if we try to compare that with the steady state equation, it's just okay because we are not time independent really, sorry. So we are not basing as per the time. So something like that. That's why it's a steady state law. So when we mean of a steady state law, usually we will follow the continuity equation. Continuity. This is not an election na continuity si 30, yung musulog na po si Bongo. It's not like that That is a continuity in the election process. Okay, but here, continuity in the science equation. Something like that. So how can we do that? Magbalik na punta sa overall material balance. OMB. And also the CMB, component material balance, and also the EMB, energy material balance. Okay. Okay, going back. Overall material balance is more on the physical separation processes, something like that. And then the component balance is more on the study of the, how fast or slow the chemical reaction really is, the chemical reaction engineering, the kinetics, because component measures of concentration and solubility. And the energy balance is more on the physical chemistry and the thermodynamics. Because usually the study there will be more on the internal energy, ganon siya chuba-chuchu, gives free energy, entropy of the system, ganon. Alright, so it's more on the energy basis. So it's gonna be like that. But somewhere along the way, you can correlate the three. It doesn't mean that kung energy siya, energy na lang yun siya. What I'm telling you that the general, it's gonna be like that. Okay? So mga ganon siya. Na mga uban yan, magsalib ka siya sa state functions, right? Initial and final. So usually mga unsa man na siya mag-involve ra gyud niya ng higayuna kanang mga heat, right? Heat content or enthalpy. Enthalpy change of formation. Ganon, di ba? Mga initial and final state lang yun siya. Okay? So, final temperature. Initial temperature, final temperature. So, wala na kakibaw sa in-between. Something like that. Di ba? Or, unsa na siyang hitabo sa tunga-tunga. Pero sa kinetics man good siya, guys, sa chemical reaction engineering, we need to know what's in between. If you have the reaction in the initial state, you have also the product side chemical reaction. And we need to determine the intermediate reaction in between before going to the products. That's why we can come up with another equation of, Michaelis-Pugnali equation, hanggang ganon. Dili lang kay kang Arrhenius equation sa kinetics. Ito mga first order, second order, third order, something like that of reaction, hanggang ganon, di ba? Okay. You get the point? And time-dependent na yun siya ang chemical reaction. Okay, rate man siya, guys. Okay, rate of chemical reaction is equal to the rate of the product concentration over the rate of the concentration of the reactant. Something like that. Okay? And then, erase mo siya sa iyang mga mga coefficient. O ganon. Diba? We will never go to the reaction kinetics, of course. Okay? Mga ganon. Chupa-chuchu. Because I vlogged that also last month. Makalimot ko sa to siyang buwana. Charot! Okay? Ganon. So, okay. Mag-draw sa taong kuan. Hay, nakakaloka. Okay, this is our ganon. Makita niyo guys? Nindot ba akong square chart? Okay, so this is our feed. Okay, F. And this is our product P. Okay, it's gonna be like that. You got the point? And then it's gonna be our recovery. Here, recovery. So, if we have a generation or a loss, we have a recovery. So because we cannot recover if we don't have loss, right? Common sense. Okay, and we have also our consumption here. Here, consumption. If our solution are being consumed, kung to na siya dito sa tunga, sa imong vessel, na siya sa suit, ma-consume ba siya dito? But normally, it will never be consumed, right? Because it will go to another lines pa siya. So, but I am showing you the ideal overall material balance. Okay? So, let's say, consumption is siya. Napagit siya yung mga accumulation, chuba, chuchu. Accumulation. So, letter A here. Let's say accumulation. Ganan. Okay? So, accumulation. Muna siya, no? So, you have a feed, you have the accumulation, you have the recovery, if you have a generation and a loss in your balance, and then we have the consumption, and you have the product. So, in a steady state equation, di ba, mudit surat tag-ingon nga input is equals to output, muna atong ginamaster sa engineering, right? Especially sa BS Chemical Engineering. Mudit surat tag-ingon, input is equals to output. What comes in, what comes out. Actually, it's not like that. The situation to be like that because we treat that as a steady state equation or a continuity equation. But what if it is a steady state equation? We can never use that kind of material balance. Okay? Mauna siya atong timan-an permi. Guys, di ta magsalig sa katong steady state ragid siya permi nga, input is equals to output. Kaya di man na permi ang ana. Ang problem na may mga steady state na mugamit ka itong mga differential equation. For example, heat transfer, you will use the heat transfer nga equation, you will use the, for example, the Euler's, momentum transfer, you will use the Euler's equation, Navier-Stokes equation, mga ganun ba? Aside from the Bernoulli equation. Okay, na dagan na kasi mga integration, integrate, differentiate. Na di kita mo use ana niya kay ato kita sa Bernoulli, right? Nakatong steady ra kay siya ba? Na sayo na kay siya sabton, di ba? Pero actually we can use that one if our problem dictates us to solve unsteady state complex problems. But it just happens that our sample problems in our engineering course are usually, I think, 80% up steady state. Okay? Because nag-avoid sa nga complex ba? Sa complex nga understanding. Complex yung kayo siya kung mag-permit unsteady state. Magsige na lang kuan dito, Laplace equation. Magaganan. Kung mga advanced engineering mathematics, differential equation, mabuang ka ng mga limits. Di man na pwede ma-apply good sa real world. May anak. The limits, di ba? And then mga usapan na diha, mga Laplace equation, di ba? Siya sa advanced engineering mathematics. Mo resort kita sa pinaka-basic atong Bernoulli equation. Okay? Muna siya ang may tabo. Okay, muna siya. So, mingamin ka nga, input or accumulation. Okay? Mo gini siyang istorya, guys. This is the real source. Accumulation is equals to input, okay, minus output, okay, plus the, minus the consumption, okay, consumption plus the recovery, okay, muna siya may tabo sa itong overall material balance. Atong, guys, ang atong recovery positive, kaya mo siyang gi-recover. When you recover something, it will become a positive. For example, if I have spent my money and I want to return back the product I bought, then I have to recover it back. So that is a positive for me, not negative, right? So the recovery is positive, okay, and then the consumption is try to be a negative. When you consume something, it will be negative. It will not be far away from you. It will be no longer yours. When you try to consume that in your systems, imong lawas, wala na siya sa imong atubangan. So it's being consumed. It's being totally converted to other products, and it will be, released and expel out from your body, something like the consumption. Okay, this is negative na. Okay. So in here, there's no accumulation because we don't introduce other chuba-chucho in your feed. Okay? Mga sa panadang ipangpuno ni mo di ara, mga additives, or whatever, para ma-intensify ang imong raw material. Wala nakikipuno ba? Katulad yung siyang standard procedure imong gisunod na maora dito yung mga raw materials. So, maora dito imong feed. So, wala na yung mga accumulation chuba-chucho or mga unexpected nga marmutunga ra og kalit when you do the process. May mga tagak dito baron nga mga kuan, residue nga musul dito sa imong tank, muna ang mga accumulation nga dili nimo mahibaw-an. Okay? So accumulation will be automatically zero. We assume this is an ideal material balance. Ideal overall material balance. Okay? Now, kung wala na siya, ang accumulation will be equal to zero. Ang imo nga kaya recover because you have no loss, you have no wasted energy, it will become zero. And since the feed in your process vessel is not yet consumed because it will go to another lines to lines because your product is very, very far pa siya, process A, process B, process D. So your consumption also is not, no value pa siya. Negative siya, so zero. Okay? And then this is the time, you will have believed guys, input minus output. So in algebra, how can we do that if we equate that to zero? Input minus output is equals to zero. So algebra na dayon ta. Di ba? Nag-science ta. And after that, we need to relate to algebraic expression. So it will become input is equals to output. Okay? Mauna na siya ang basis sa kanang steady state equation from chemistry to higher science engineering topics in engineering courses. Not limited only to chemical engineering, but I think also mechanical engineering and mining engineering are using this steady state equation. So mo na siya ang input is equal to output, which is the basis of the law of conservation of mass, law of conservation of matter, law of conservation of energy. There is an equality sign in between input and output. Equal siya talaga, guys. And this is time independent. So we held time as constant somewhere along your process. Okay? Time independent siya. So time is constant. So we treat time as irrelevant in this case, in the steady state. Kaya kung in that case, kung ato siya i-consider, it will become an steady state equation na dagan kasi mga pasikot-sikot, chupa-chucho. Okay, now input is equal to output. Muna na siya hitabo. Okay? Now, asa na siya ma-apply mo? Dagan kayo, muna siya this will be applied in distillation, extraction, okay, absorption, in fluid flow, in fluid mechanics, heat transfer, heat exchanger problems, evaporation problems, crystallization, drying, centrifugation, leaching, sedimentation, flocculation, filtration, a lot of physical and chemical separation processes and even transport phenomena use this concept in a steady state equation or the law of continuity equation. So, okay? So, dapat ingani ang pag-explain. Nanong mo kalitra of input is equals to output, ha? Okay. Kinana siya hinungdan. Okay. Kung nakasabot mo ni ibig sabihin sa pagtutuan ang problem solving, na siya chance ma-solve ni mo kaya nakasabot magod ka. Okay? Okay guys, it's very clear. Ako nag-erase. Nakakaloka. Now, adto ta mo consider ta first sa katong mechanical energy. Okay, mechanical. So mechanical energy Sotero, that is an energy driven by motion and movement again. Mechanical energy is an energy driven by motion and movement. The movement or motion could either be artificial or a natural process as long as it is in motion and in movement. It doesn't mean all the time equipment. Okay? Like that. Literal ra na siya nga explanation nga if you speak of mechanical equipment na dayon ang masud atong una-una dili anything that acquires motion and movement is already mechanical. Okay? Meaning dynamic movement, motion. Okay? So, ang ato lang nasabtan kay lagi na may mga equipment mo na siyang mechanical siya. Pero ang pinaka basic definition is a type of energy driven by motion and movement of a particular, let's say, muna matungan na ng equipment, machinery, object, substance, like that. Okay? It's very clear, right? That's the definition of mechanical energy. Now, natin mechanical energy. Okay? Okay? Mechanical energy. Okay, ganon. So when we speak about mechanical energy, what comes in our mind? What are the two types of energies that usually involve in our mechanical energy? Maghinumdum na katong physics. Okay? So, musulit sa muna-huna, ang katong kinetic energy plus potential energy. Okay? Now, you need to understand this, guys, because this kinetic energy and potential energy is very useful in transport phenomenon related to momentum transfer, fluid flow, fluid mechanics, fluid dynamics, quantum mechanics, statistical mechanics. Okay? Mao gyud siyang pinaka-basis ang potential energy and kinetic energy. Okay? Like that. Now, we will also consider the fractional energy. But again, man siya, guys, katong na mga coefficient of fraction, right? Na siya mo resist. That is, the fraction, right? So, kung solid surface siya, na kung fluid siya, the viscosity is just the same with the fraction, right? Kaya mo resist man siya sa flow. Okay? Or then, kung friction mo resist siya sa movement. Like this, I'm standing here. So, kung rough ang surface, mo resist ang movement sa akong tiil. So, that is fraction. But in terms of fluid and liquid and gas, it's not like that. I-resist niya ang flow sa fluid. Dili ang solid surface. So, pero mao ang iyang pareho ra siya og purpose. The resistant to flow and the resistant to move. And viscosity and fraction is just the same in concept, but the application is on the another phase of matter. Okay? Get the point? Because viscosity is more on the fluid, liquid, and a gas. But fraction is more on the solid surface exclusively. You get the point? So opposing force or a resistance to flow or resistance to move, something like that. Okay, so kinetic energy plus fractional energy. Katong gamit ang mu, coefficient of fraction. What's good in here, guys, because usual physics man gud siya, dili na siya mo undergo mga fraction chuba chocho. I-assume niya jud Bernie nga ang kuan soft ra jud siya ang surface, ganon. Mo na mawa na siya pa ang fractional energy. Okay? Pero kung butang ani so po ninyo, charot. Di ba? Simple as that. Okay? Pero kasagaran mo gud wala. Okay? Get the point? O muna siya may tabo. Okay. Now, mechanical energy na siya, no? Nakaroon, naging matag points. For example, ako'y point 1. Okay, point 1, point 2, point 3, point 4. Ganon. Yun yung naman steady state equation. So, we need to equate the movement of your molecules in 1, 2, 3, 4. So, we can also say mechanical energy is equal of point 1 is equal to the mechanical energy of point 2. Oh, iha, putlon. Mechanical energy of point 2 is equal to mechanical energy of point 3. Putlon. Mechanical energy of 3 is equal to mechanical energy of 4. Putlon. Now, unsa may definition sa mechanical energy? Kinetic energy plus potential energy. Imo na ibutang tagsa-tagsa diri ari. Minila, kinetic energy plus potential energy in point 1 is equal to kinetic energy plus potential energy in point 2. Ganun siya chupa-chucho. Kinetic energy in point 3 plus potential energy in point 3. Kinetic energy in point 4 plus potential energy in point 4. Okay? So, your energy is being conserved. Right? Because you equal that to among the other points. So, you have now conserved. That's why it's law of conservation of energy, of course. But what are being conserved here are specifically your kinetic energy and the potential energy. Okay, now, we should go back. What is the basic formula of kinetic energy? So, imo din mo na siya 1/2. Kaya mo siya natin sa high school pa ta, di ba? I-memorize lagi ang formula ng mga ingani. So, 1/2 mv squared. So, this is at point 1. Okay? Times sa formula sa potential energy. Ganon. So, we have the mass times g times h, or the acceleration times the height, right? Muna siya at point 1. I-equate din mo siya talaga ng aning Kapoy lang yun siya buhaton, no? Pero mag-antos jud ka if you want to become an engineer. Okay, mao man jud ang life sa engineering. So 1/2 mv squared, okay, 2 times mgh 2 until chuba chucho. Mura na siya, ikot-ikot din mo siya. And then ang problems na may mga given, di ba? Ipasok din bingo. Ipasok din kung saan ang mass, kung saan ang velocity, o ganun siya. Ang nanawin ng question. Let's say, an ammonia will go to a diffuser with a flow rate of 2 grams per hour. Una, di ba? Then, at a diameter of 1 inch, okay, what is the velocity when it go out to the end point? Something like, makuha din mo, kaya naman mahinga-hinga, di ba? So, substitute, tingnan na ka-simple. Okay? But the only problem kung halo-haloan siya mga chupa-chucho, nga dili ba siya related? For example, ngani, sa bulan siya mga viscosity, nga katong mga uban-uban pa dito nga, makalibog siya ba? Muna siya ang tricky part sa engineering questions. Kaya naamag yung mga time nga ilang ipuno dito, bisag dili na ka siya kinanglanon ba? Okay? I-mention pa yun niya ang temperature, i-mention pa yun niya ang pressure. O sa kalabutan sa temperature pressure, kung energy lang yung quadriary. Okay? So, yan ang yung dimension kasi mauna siya ang imong kuan nga makuha baron at the temperature nga viscosity nga makuha at the temperature. Nakibaw man ka nga viscosity related siya sa velocity. Di ba? Ganon. Ano nakaingkon ang viscosity is related to velocity? Because of the formula of Reynolds number. Okay, Reynolds number is equals to the velocity times density. Ganon siya, chuba-chucho. Okay, get the point? And then times the length over the viscosity. So, mo nihatag ang problem of temperature. Kikwaon mo ang viscosity at that certain temperature. Pero nigamit ka o concept na mechanical energy, motion sa fluid. You get the point? Ang purpose lang niya para makakuha ka of other quantities through this your equations here. Ganda siya, chuba-chucho. Okay? Or either the mass there is not given. Right? The mass there is not given, then you can compute for the density. So density is equals to mass over volume. Ganun. Or either makuha nimo ang density through this Reynolds number after makuha na nimo ang Reynolds number. Okay? Ganon. Okay, density mass over volume ano na ka density of volume. Makuha din mo ang mass mo na isa kay di man sa tanang higayon ihatag na diretso ang mass. Okay? May pasikot-sikot pag yun siya ba? May nakaparat. Okay? Diba? Sometimes ganyan, butangan dyan. Dito siya butangan. Muna ra siya. A water flow, blah, 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 so and so. Calculate the velocity of the flow that will go to the outlet. Imagine, walay given. Okay nga. Ano makakuha man ka? Because of theory and concept. Nga naa siya density sa standard condition. Ganon. Na kung nasa density sa kalkulado, dali na kayo makuha nimo ang mass o ang volume, kaya naman kayo molecular weight sa water. Haladay, 18.016 grams per mole mo na molecular weight sa water. Yun na may relation ng molecular weight sa mass, sa molar mass. Di makuha din nimo ang mass. Chararat. Okay, kung dili pa dyan ka kontento, kaya wala kay moles, then have a chemical reaction. H2 plus O2 is equals to water. I-balance nimo ang chemical reaction. Then get the number of moles sa water. I-substitute nimo dito sa katong molar mass. Una na po kay grams. Una na kay mass dari through your molar mass and molecular weight. Ganun ba? Nung wakto siya given ang problem. Anak rin siya kasimple. Water is flowing in the pipeline like this. Calculate the velocity of the water that will go to the outlet. Imagine wala given. So meaning to say, it is assumed to be in standard condition. Kung wala siya given, mo na siya trick sa engineering problems. Kung wala yung ganun siya nihatag any chuva-chucho na mga given, i-assume yun na nimo siya at standard condition. Kung water, kaya dali ra kayo ang water. Okay, pero kung uban mga alcohol, chuba-chucho, benzene, toluene, mo dili na nimo mapugos. Okay, pero kung water mapugos gid mo kay standard pure substance magud ang water. Okay? Get the point? Dagan ka siya mga valis-valis chuba-chucho, di ba? So malingaw ka sa water kay oh my gosh. Ang mga constant nila sa imong brain cells. Okay? You get the point? Muna siya metabo. Specific heat capacity, 1 calorie per gram degree Celsius. O ganon. Okay? Dagan kasi mga kuan ba? Sa pa dyan, heat of vaporization, 2,260. Ganon. Joules per kilogram. Sa pa, 530 calorie per gram. Ganon. Ang iyang kuan, ang iyang heat of vaporization. Okay? Kailangan mo itong specific heat capacity, kailangan mo siya temperature sa denominator. Guys, ang difference between specific heat capacity and the, what do you call this one? Heat of vaporization, kaya wala siya Celsius sa ubos sa denominator ha. Pero maorigid na siyang iyang unit, chuba, chucho. Diba? Batan ko ang heat capacity of water at 25 degrees Celsius, di ba? 1 calorie per gram degree Celsius. Now, tangtawin na lang mo ang degree Celsius, mauna na ang heat vaporization. Okay? At the same time, that will be your heat of condensation. Okay? Kay reverse man siya, pero negative ang value nimo. Kay reverse process ang condensation ug ang evaporation or vaporization. So the same value ra gid siya when you talk about latent heat. Latent kasi tawag yan latent heat of condensation and latent heat of vaporization. Okay? Muna siya yung matabo. Latent. Pero pwede ang uban, pwede lang dibutang latent. So, mauna na buot ipasagot. Okay? Ganon. So, namatay nga niya, mechanical energy, naman natin ang gamiton. So, naman tayo formula, so dali natin makuha. Okay? Now, ito pa sa impulse. Charot. Kaloka. So, Sotero, si impulse. Impulse is force times time. Momentum is equals to mass times velocity. Mga ganun chupa-chucho. Okay? Okay, impulse. Actually, impulse na kina siya magamit, pero sige lang. Makulit mo sa momentum. Impulse is equals to force times time. Okay? Momentum is equals to mass times velocity. Okay? Ganon. So, kasi timanan mo guys, pag impulse force, right? Ang timanan mo sa momentum, ang velocity, nagit siya velocity per minute. Okay, una na siya. Ang papasok ha? Okay na, ang iyang unit, klaro na kayo yung unit kilogram. Kilogram, meter per second. Muna na yung sa momentum. Yung kanina siya, Newton second. Ang impulse. Okay? Ganon. Ang Newton, yung muna siya i-break sa kilogram meter per second square. Muna siya ang Newton. Okay? Muna, makonvert yun mo sa Newton pa ang given, makonvert din mo sa mga meter, chupa, chucho, kaya i-break pa mo siya ani. Okay? You got the point? Ganon. Ang napapasok ha, ipasok na sa inyong brain cells. Ganon lang siya. I-register din sa inyong brain cells. Okay, gamay naman ako magnetic board. Charot! Okay. Now, ato ta sa pinakasimple nga equation. Di sa pinakasimple, Lisod-lisod gamay. Okay? Kay, moingon na siguro ko kay engineering man akong kurso, pero takibaw ang umanisat kasabot ba? So let's go to the basic math equation. So, okay? Okay, guys. Hala, did you day mahuman og sa kaadlaw no kung i-discuss nimo tanan? Really? Okay? Labi na ang mga stock knowledge, yung ganun. Okay? So, isama na nato siya, guys. Okay. Okay, magsugod gyud ta sa katungkuan. Kay pasahang ako sang hinumduman. Wow. Because that was 20 years ago. Okay? In my college education. Okay? So magsugod ta kani ano ko continuity equation no? Continuity equation. Guys, atong hinumduman, we should remember that in a continuity equation, most of the flow there is laminar flow. Meaning, uniform directional movement of your flow. Very uniform. Okay, the molecules movement. Something like that. So that is laminar flow. So that is less than 2,100. Okay? So this is in the stage in which there's too much EDS here. EDDIES. Kung the more it will produce EDS, the more it will become turbulent. So the turbulent will be the reverse, greater than 2,100. Okay, this is by using Reynolds number again. Okay, velocity, density times the length over viscosity. Okay, you get the point? Something like that. And then, how can we compute for the viscosity? Something like that. So we need to follow the other formula. So, kinematic viscosity. Guys, daghan jud kaayo, pero sige lang ha. Kinematic viscosity is equal to dynamic viscosity chuba. Okay? Dynamic viscosity over the density. I shall put a raw Greek symbol directly as a density. So raw, the 9. Then, raw. Just like alpha, beta, gamma, theta, phi, epsilon. Okay, symbols, Greek symbols. Usually our previous scientists in the past. Okay, something like that. So this is our Reynolds number. Okay, this is our kinematic viscosity. Now, we can compute this viscosity in another version. Wow, parang kanta, no? May version pa siya. Okay, so it's gonna be ganon siya. Length raised to the power 2 over time. Length squared raised to the power 2 over time. Di ko din ako siya kalimutan. Kaya ano, mo siya dito sa kung ano sa momentum transfer sa fluid flow. Huwag yun siya per me, guys. Okay, so ang atong length meter squared. Yeah. Atong time is second. So na natin meter squared. Muna ang unit sa atong kinematic viscosity. So in here, guys, it's referring to kinematic viscosity, not the dynamic viscosity. Here. Be careful, okay? Ang dynamic viscosity is equals to kinematic viscosity times density baya. Okay? So we should be careful. And this one, guys, nasa na siya value in terms of centimeters squared over second. Okay, mo na siya ang katong biingon din yung kama centipua. Okay? 1 pua is equals to 100 centipua. Pua meaning poise. P-O-I-S-E is the unit of your viscosity. But it is also equal to 1 centimeter squared over second, or it is also equal to 100 centipua or 1 pua. So that is your kinematic viscosity. And now we have also your dynamic viscosity. Take note that there has another unit for this dynamic viscosity. So, ang kanisya, mo na siya ang Pascal, nagkalisod gamay, no? Sige lang. Pascal second, and then kilogram, gano'n siya chuba-chucho. Okay? Kilogram, then meter second. Here. Okay? Like this. So, mo na siya. Okay? Then, 1 Pascal second, 1 kilogram meter second as an ubos, okay, is equal also to another unit of viscosity, which is the stoke. Okay? This is equal to 1 stoke. Muna na akong giingon ninyo. Tungod ni Mr. Navier-Stokes. He discovered the equation in the fluid flow or in the momentum transfer na katong na yung mga differential equations, di ba? Teka, Bernoulli, simple raman iyaha, right? So, mo ni siyang na-spoke, tungod ni Mr. Navier-Stokes, ang kaning dynamic viscosity. So, if our question in the future will say, who discovered the dynamic viscosity? Yan, walay choices. Fill in the blanks ra gyud siya. Ang imong answer, Mr. Navier-Stokes. Okay, what my choices? Fill in the blank. Naklaro kayo diri o? Okay, mo na. Pero kung mayon siya, mayon ganit ka, who discovered viscosity o kana pagtalunan pa na siya. Because ang i-discovered ba yan ni Navier-Stokes, specific man siya, dynamic. Inaaman sa kinematic viscosity. Now, kung fill in the blank, mapugos kag answer ni Navier-Stokes kay related ra magud siya kay basig wala gyud ay ni-discover sa kinematic viscosity. So it could be interpreted as Navier-Stokes also relate that kind of viscosity in his discovery. Something like that. So answer ka ni Navier-Stokes rather than you will not be answering, wala kay points. Okay? So answer ka ni Verstock gyapon. Bisag ang discovered ni Verstock ang dynamic jud siya, dili ang kinematic. So we don't know. There's a correlation between dynamic and viscosity, which totoo naman siya dito sa equation. Girelate naman yan talaga. So your answer will be ni Verstock. Okay, sa mo na nga question. Now, kung multiple choice, wala din siya. Who discovered kinematic viscosity? A, maganda siya, Michael Faraday. B, Heinrich Friedrich. No, nakaloka yung Heinrich Friedrich. Sorry. Friedrich Heinrich. Katong na-discovered siya sa kuan frequency na Hertz. Siya man ana. Heinrich Hertz. Yan ang discovered a frequency tungod sa photon. Release of photon energy sa light. Grabe kayo, no? Diba? All we have to do is to, expound our knowledge. Okay, now ano siya? So, ano yung answer ng gayon na, ni Verstock dito siya ay kalibog. Okay? Ganon ha. Oh. So, muna yung answer ni Verstock. So, gilibog ra mo ni ini guys, kanang meters per second, maugit na siya ang standard unit sa kinematic viscosity. But this is not the one equal to 100 centipua or 1 centipua because it is the centimeter square over second. Kaya masayok mo sa inyong computation. Okay? Because sometimes guys, maugit na siya ihatag sa problem, especially sa momentum transfer. This would be siya ingon, one stroke of non-Newtonian fluid or Newtonian fluid, let's say, usa ba na siya diha, cyclohexane, benzene, chloroethane, usually organic substance. Okay? Muhatag din siya mga stroke diretso, muhatag din siya mga sentipua. Kung wala kay idea nga, kung sa mga breakdown ni anang mga kuan, di ka kuha. Kaya naman siya mga equivalent sa manini, Pascal second, kilometer second, meter second. Diha man mo makuha, ini kakuha nimo, ka-calculate nimo bakit ang katong velocity na abi meter sa tumoy. Velocity, meter per second. Wa ni meter ang kuan, ang stroke na mabuang na lang kag kinonvert wa gyud day meter per second. Imo jud nang i-break down. Okay? You get the point? Muna siya kay na related din siya sa velocity. Basta mga viscosity chupa-chuchu. Okay? Muna na siya. Continuity equation. Okay? Dito sa ako papasok. Suwat pa sa inyo mga papil-papil diha. Okay. Now, muna siya ang steady state equation. Okay? Steady state equation. Okay? Muna siya. Papasok na nako. Ala, tanawa sa ninyo muna, di ba? Nakakaloka. Perfect! Okay, bisa kung scripted ra siya. Kung wala siya script, no? Disura dyan ko bahala na. Okay? Muna siya guys, ha? Di ba? Charot ko Okay. Now, balik ta sa Bernoulli. Ano importante makain ni Bernoulli? Charot. Hala guys, why? Bernoulli equation is my favorite equation in momentum transfer. Ganun kay kuan. Charot! Uy, charot lang ha. Okay? Okay, basig mo kuan sa mga kuan. Okay? Okay. Muna na siya, no? Ato na siya ikuan. So, atong inumbot doon naman guys na naatay Bernoulli. Okay, Bernoulli equation. Okay? Nga-use ni siya sa momentum transfer. Fluid flow, fluid mechanics. Hinapod tay kuan, Newton's law of viscosity. NLV. I-memorize na lang guys. NLV is Newton's law of viscosity. Pareho na siya application sa momentum transfer, fluid flow, fluid mechanics. And then we have also the Fourier's law of conduction. Okay. FLC. Fourier's law of conduction sa heat transfer ni siya sa conduction. So, sa itong conduction, the heat transfer through solid particle or solid substances. Okay? Like that. Or solid as your medium. Okay? Muna siya ang Fourier's law of conduction. Now we have also the Newton's law of cooling. Muna ni siya sa convection. It is a heat transfer, okay, from a solid or a stationary fluid to the moving fluid, liquid, or gas. So combination of the three phases na talaga siya. If we talk about convection and our temperature gradients, there will be the bulk temperature, the ambient temperature, and the infinite temperature, the temperature, and the wall temperature, and the surface temperature, right? Okay, muna yung mga term dito. Yung muna siya mo gamit na ka Stefan, mga ganon. Okay, Boltzmann constant, mga ganon, okay? So this is Newton's law of cooling. And number 5, ato din siya sa mass transfer. Charot, ay. Muna na siya ang fixed law of diffusion. FLD. So, diffusion na nakasagaran dito sa heat transfer, ha? Mass transfer, katong mga concentration gradient. So, diri ari concentration gradient. Okay, diri ari kuan siya heat transfer temperature gradient, diri ari. Okay. Diri ari is velocity gradient. Now, if the question in the future will say, blank is a scientific law that based on velocity gradient. So, wala din siya A, Newton's law of viscosity, B, Euler's equation, C, Fick's law of diffusion. So, your answer could either be a Bernoulli equation or the Newton's law of viscosity. Okay? Something like that, okay? So, pili-pili din ka dito kung mga butikaw, ikaw, kung multiple choice. Okay? Pili din siya. Ano siya? A transport phenomenon, because singular, a transport phenomenon based on concentration gradient or solubility gradient. So, that is the fixed law of diffusion. Ganon. Hindi mo na siyang tinanan. Fixed law of diffusion. Mr. Fix. Okay? Muna siya. Fick, Newton. Bright si Newton. In fairness. Kinagin siya yung mga Newton's law of viscosity, Newton's law of cooling. Napagin na siya 3 laws of motion sa physics. The law of inertia, the law of acceleration, and the law of interaction. Okay. The law of inertia, that is, a body will continuously moving unless acted upon by a net force. And then the law of acceleration, it is an object will move through its force multiplied to its acceleration covered. And then the third part is the law of interaction. In every reaction, there must always have an equal and opposite action or interaction, something like that. Okay? In every interaction or in every reaction, there must always have an equal and opposite counteraction or action. Moro na gyapon siya, di ba? Moro na siya ang akong thought. Muna ako gi-memorize word for word. Okay, moro na ako nasabtan. Okay? So muna siya ang katong free of falling body, katong nagpungko si Isaac Newton dito sa kahoy, nahug ang apple, ganon. So, law of free falling body belong siya sa katong third law of motion from Isaac Newton. Okay? Muna siya. Then, pwede itong mga Newton, chuba-chuchu, guys, katong nasa katong universe. Hala, katong yung ka na, universe. Katong kung ang gravitational force in the universe is equals to the force times the diameter 1, diameter 2 over r squared. Okay? Again, gravitational force in the universe discovered by Newton. Again, bigyan na discovered ni Newton, pero in this time sa katong universe, ni correlate siya ni katong Johannes Kepler sa yung 3 laws of the universe na mayon ka na F is equals to G m1 times m2 over r squared. When G is the gravitational force constant na katong kuan siya, katong 5.67. Ganun times 10 to the negative 11. Diba? Dito siya kalaghanan pa ni Newton. Nung siya nila ang father of modern physics. Si Isaac Newton. Okay. Oy, taas na dyan ko gidaganan. 1 hour and 24 minutes na. Okay? Okay, guys. Now, Bernoulli na ta. Steady state equation. Take note. This equation of Bernoulli cannot be applied in a turbulent flow. That's number 1. Number 2, this Bernoulli equation is exclusive to momentum transfer and fluid flow, or fluid mechanics, fluid dynamics, something like that. Okay? And this Bernoulli equation applies in energy equation, in a continuity equation. Okay? Steady state, laminar flow, uniform directional flow. Okay, may siya. So, natay ko ang pressure of the fluid, okay, plus the dynamic pressure. Okay, yung na 1/2, okay, mv squared, ganun siya, times the, ato pa din siya times of density. Okay, ganun. Plus mgh. Okay, like that, and then times the density. Ganun, is equals to 0. Okay, like that. Now guys, okay, P is the static pressure at its rest, or stored pressure when an object or a fluid or any substance does not move yet. That's why static pressure. Okay, static pressure or the fluid pressure at rest. Okay, at rest or not yet in motion. Okay, yan. This 1/2 mv squared over 2 is the dynamic pressure. Okay, and this density in GH is your based on your, unsa man siya, hydrostatic pressure. Okay, meaning there's more applicable to the water, hydrostatic pressure. Okay, now take note guys, napa siya yung mass. Okay, mass, nasa siya yung mass. Mama na siya original, these are the original, kung ano na siya yung mass, nasa siya yung density. Okay, so in this situation, the Bernoulli equation is assuming that there is a 1 pound or 1 gram of a substance flowing in the system. So if it is just 1 constant, okay, assuming that the mass is constant, let us say at your basis of calculation is only 1 pound or 1 gram. Diba? If you multiply to a certain 1, it will not be having a value, still 1. So that's why this mass will be eliminated. Okay, based on your scientific assumption na constant ang imong mass somewhere along the way in from point A to point 2 to point 3 to point 4 because your concern is the velocity gradient or the changes in the velocity. Okay, muna mo constant pa sa mass. Okay, ganun siya. But it doesn't mean we need to constant the flow rate, huh? I'm talking only for the mass exclusively. Gram, kilogram, token. Ang flow rate lahi, naman R sa denominator. Okay? So I'm not talking for the flow rate yet. Okay? So constant ang iyang mass. So may cancel na to ang mass. Okay. So what will be left here is pressure, static pressure of the fluid plus density V squared over 2. This V is velocity. Okay, plus density times the gravity times h is equals to 0. Lesser, so you say gravity. So the gravity is also 9.81. Ito ang discuss yesterday. 9.81 meter per second squared. Okay? Ganon. Okay? Now, okay, multiply na mo siya sa density. Ang density sa, let's say water will be flowing here. Water. At 4 degrees Celsius, di ba? Ang water, na siya, may density niya. So water, okay. Water density at 4 degrees Celsius is either 1,000 kilogram per cubic meter, 1 kilogram per liter, 1 gram per ml. Okay, ganun siya. And the other value also is 1 gram per cc or cubic centimeter. Why? Because the cubic centimeter or cc is just equal to milliliter. Muna moingon ka dito, ang 1 gram per ml is equal to 1 gram per cubic centimeter. Okay? Ang lahi ra gyud niya tungura kay 1 kilogram per liter man pud siya in terms of liter. Ang only na imong ipasok sa imong brain cells, ang nalahi ra gyud siya ang katong kilogram per cubic meter. Kay 1,000 kilogram cubic meter is the standard density of water at 4 degrees Celsius, not 25 degrees Celsius. Okay? Yung mo natong basis or reference during the, the experimentation of our previous scientists. That's why they come up with this standard density. Okay? Ganun siya. So, multiply na ito. Let's say, meter per second squared naman tali ara-ara. So, napod tayo meter nga masud. So, unsa man ang value sa density nga na meter. So, ang kilogram per cubic meter. So, muna mo gamit kag 1,000. So, 1,000 kilogram cubic meter. Okay? Hinatay height. H. Ang height is a vertical distance or what we call a head. Muna sa mga terminology na put this in your brain cells. If you speak about head, okay, usay ingon ra siya sa problem. The head pressure is 2. Dili na ba ipa-explain kung saan ang head pressure, sir? So dapat makabauta. Ang kanang head pressure is also equal to elevation pressure. Okay? Is also equal to the vertical distance pressure. Okay, ganun siya. Muna siya ang mga elevation. Vertical. Muna siya ang head pressure. So meaning, muna siya ang value sa pagkuhan sa pressure in terms sa head. Okay? Head, elevation, and vertical distance, and height. Maura yun na siya pirmi. Okay? Now, ang height, pila man ito ibutang kay meter naman siya. Sa meter na siya. Okay? Ato ng purpose kung makakuha ba tag unit na mo pasok diri ari sakto sa Bernoulli. Okay? Ganon. So, cancel. Charot. Cancel. Ganon siya, chuba-chucho. Kung saan mahabilin. Okay? So, cancel. So, na mahabilin nga M2. So, cancel. So, ang mahabilin kay kuan. So, kilogram, meter, per second. Right? Ganon. Tanawa ang unit niya. You got the point? Ang unit niya. Tanawa ang unit niya. Kilogram, meter per second. Ganon. Then, ang diri-ari. So, ang yung unit diri-ari mo ng kilogram per second. Diri-ari. Okay. Ang kani siya, si kaduha. So, density. Okay, density, kilogram, cubic meter. Okay, that's velocity meter squared second squared over 2. So, meter squared. Cancel siya. So, kilogram meter squared. Ganun siya. Diba? Meter. Yan. Kilogram meter squared. So, ang unit, kilogram meter squared. So, dili siya pasok sa banga. Okay? Ang pressure na ito, kani siya nga pressure. Di ba na ang unit of pressure? Pascal. Pascal, atmosphere, bar, torr, and mmHg, millimeters of mercury. Muna siya yung mga units sa pressure. Right? So, let's say Pascal lang yun ni siya. Ang Pascal, kaya kung ano na siya, Pascal is, nakalimot ko, but sige lang, kilogram, meter, Newton per meter squared ang Pascal. Okay? So, kung makalimot ka guys, imong hinumduman na pressure is equal to force over area. So, N man siya, force man siya, ano man kung mass. So, ang ang atong brain cells, dali na kayo mo catch up. So, force over area, so, Newton over meter squared. Kung siya yung value sa imong pressure. So, dapat kani siya tanang yung tanang yung unit para mo agree. So, kung saan man mo siya pag-convert, namin mo siyang Newton meter squared, na mag-abot din siya tanan. Chararat. Nakakalong pa. Diba? Na mag-abot din siya tanan guys, kung saan man na siya. Okay, so, dire mo man siya kilogram meter cube, ikansal man mo siya, meter squared naman na siya mabilin, ana-ana. Okay, so pila naman dyan yung value na ng higayon na. Okay? This is squared guys, sorry ha. Tapos ha, squared siya. So, kuan siya, equal na siya kaming duha. Di ba? Diba? Meter second squared, 1,000 kilogram meter cube. Bali maglaban na itong ulo ba? Itong i-simplify. Okay? So, times meter na mabilin. So, since kung ano ni siya, wala man siya secondary, so kilogram meter second squared. Pariharan siya ani kaduha. So, kanina sa aman na ito siya mahimong kilogram meter per second squared. Na Newton pa man ni siya. So, atong ibungkang. Charot. Okay. Newton is kilogram meter per second squared over meter squared. Cancel, cancel. So, it will become also kilogram meter second squared. So, pareho na siya tanan. So, correcta. Okay, so we can add this already as our Bernoulli equation. Kaya pareho na naka-obtain ng kilogram per meter second squared in our static pressure. And then, in our second term, this is term in algebraic expression, right? First term, second term, third term. Okay, in our second term, in this dynamic pressure, we obtain also kilogram meter per second squared. And then in our hydrostatic, we also obtain kilogram meter per second squared. This contains the same unit, so we can add simply. Or else, we could not have this formula. And then, perfect. This is a perfect formula for Bernoulli equation. Okay? Ako lang yung i-prove. Okay? Okay, who knows, our memory fails. Okay? So, mo gina siya equation, guys, sa Bernoulli. Pressure plus density times velocity squared over 2 plus density GH is equal to 0. Ano na siya? This part, guys, here is more on the kinetic energy. This part here is more on the potential energy. And this part here is only the static energy. Static, not moving. Okay? Here. Now guys, if you consider from point 1 to point 2, niya nakakay ka ng kuan baron, pipeline, na may mga elevation, diba? Kung imong pipeline guys is just straight, and there's no 90 degrees, there's no elbow, 30 degrees, there's no T pipeline. So automatic, ang imong elevation will become 0. Okay, wala man siya mo change ang elevation, straight ra gyud siya. So ang gimina niya ang elevation gyud sa imong physical connection sa imong mga pipelines, tanks, something like that. So kung wala ni change ang yang elevation, zero ni mo siya tanan kani siyang expression kaning third term. So ari na ka maglaro-laro diri sa pressure plus kani siya nga equation. Sa imong continuity equation nga, point 1 is equal to point 2, ganon-ganon, di ba? What comes in, what comes out, input is equals to output, mga ganon-ganon. So, muna mo isud din mo siyang duha sa input. Yan. Input, ganon. Input 1 is equals to output, ganon. 2, 1. So, isud din mo siya dari-ari, isud sa din mo siya dari-ari, but in point 2 na siya, makakuha din kag mga value. Okay, nalibog-libogod din ka sa problem, manana diya. Temperature, maglisod ka, kailangan kayo mga given. Mag-focus na dyan ka ani niya. Okay? Okay. Maglibog, me also, maglibog dyan ko kay, dagang kay ibutang bitaw, marag, sa mani, pagkapin, malibog pag-ahat ba niya, dili mo siya ang ipuntarya sa imong problem solving. Okay? Muna siya ang metabo. Ang nakakuha na ginanini guys, di ba? Ang fluid mo flow siya. Napunto dito ako mga schedule 40 nga pipe, schedule 30 nga pipe, schedule 20 nga pipe. Gamit siya guys, kanamo ko na siya internal diameter and outside diameter. Since you are talking of the fluid, so the fluid will go to the opening and the outlet. And there's an internal diameter, inside diameter, also diameter for that. And you're gonna use the pi r squared over 4 sa imong area sa inlet ug sa outlet, or pi d squared over 4. Okay, dili para sa atong kuan ha, heat exchanger, ang heat exchanger kay kuan jud siya pi dl. Okay, mo consider pa man siya sa kuan circumferential na kuan perimeter, times nimo ang circumferential nga kuan niya. Okay, but here dito sulay gud siya katong circle lang gud siya, pi d squared over 4 or pi r, so pareho ra man gyud na siya. Okay, mo na siya kay muagi man siya dito, i-relationship din mo sa velocity. Okay, muna uban mga wala diha, ang maglaro-laro diha, mga area ra ug ang velocity. Cancel ka ang ganan. Daog na dayon. Okay? So muna siya in this equation, guys, diya sa maka kung ano katong mga mass flow rate. Okay mo? Flow man akong gisgutan. So mass flow rate, ang mass flow rate kuha na siya, guys, kilogram per hour, gram per hour, pound per hour. Anything that has a mass in the numerator and time in the denominator. Okay, so it is not a flow rate if there's no time in the denominator, because that is a rate, R-A-T-E. Remember, for example, velocity. So velocity is a rate. That is a rate of change of speed. That is the definition of velocity. Then acceleration also is a rate. Why? Acceleration is a rate of change of velocity. Meaning to say there's a time in the denominator, regardless whether it is second, hour, minute, day, century, decade, whatever. Okay, as long as that is a time or month or year. Basta time jud ang denominator sa rate, R-A-T-E. Okay? Muna siya a rate of change to something. A rate of change to something. Ganan. So, kung iyon ko, guys, a question in the future, blank is a rate of change of distance. Ang sabi mong answer na niya, distance siya. The rate of change of distance. So, maglibog ka, no? Okay, so that is a speed. Okay, kung iyon ko, the rate of change of velocity is the acceleration. And the rate of change of displacement is now your velocity. It's not the speed. Why? Because velocity is a vector quantity that considers both the magnitude and the direction where your fluid flows. So that's the only difference between the velocity and the speed. In fact, they have the same unit. Okay, for example, if you're driving your car, you have kph, kilometer per hour. The velocity is also that velocity, it's also a speed. But when I will say specifically that it is a velocity, then you have to consider the direction. I will go to the east, I will go to the west, I will go to the north, I will take a U-turn, I will take to the left. So there's a direction specifically. So that is velocity, it's no longer a speed. Okay? Kinaman siya direction, point of direction. It's not only the magnitude. The magnitude is only your unit. Okay? Something like that. So, na siya diferensya. So, kung ang future examination will say, blank is the rate of change of displacement. A, speed. B, velocity. C, acceleration. D, force. E, none of the above. Your answer will be velocity. Okay. Blank is the rate of change of distance. Speed na sa mo answer. Blank is the rate of change of velocity. So that is your acceleration. Okay? Ipasok niyo yung brain cells kayo. Ano bang theory sa board exam? Okay? Muna siya. Okay. So, P star mo na chuba-chuchu. Okay, muna siya. Okay? Muna na siya kung equations per me, ha? Gan na mag-mass flow rate dayon ka. Okay, di kita mahimo ang problem solving sa fluid flow kung walay mass flow rate. Okay? And sometimes, guys, taghaan sa kag-molar flow rate, ay kabalakan ni anak na relationship, ha? Okay. So, mass flow rate, ganun. Charot. So, mass, ako lang ito MFR, VFR. Then, naman sa molar flow rate, ako lang siyang NFR. N. Because the small letter N in chemistry, in a sense, that is a unit of the amount of a substance referring to a mole. M-O-L-E. Again, blank is a unit of the amount of a substance. So your answer will be mole. M-O-L-E, not an atom, not a molecule. Again, blank is a unit of the amount of a substance. Your answer will be mole. M-O-L-E. Not a molecule, not an atom, not a particle, not a species, not an ion. Okay, mole. And this is very, very, very basic in all calculations in chemical engineering. The mole is the most basic. Okay, so that's why I put that as a letter N, F, R, because molar flow rate. Okay. Now, we need to assign specific formula for each mass flow rate, volumetric flow rate, and molar flow rate. Ikano siya, pero may na siya gawas sa examination. Okay? Sa chemical engineering. Okay? Sometimes, ato sa siya mo gawas dito sa physical and chemical principles, ganon, which basta mo connect siya dito. Okay. Muna siya. So, ang mass flow rate na to, may rin nga kuan. Okay? Mingon ta nga density times area times velocity. Okay? Yang imong volumetric matagak yung density. Mingon ka area times velocity. Imong molar flow rate sa mo niini. Kana kay wa ko nag-memorize. Okay, since I know that molar mass or molecular weight is equal to the mass, di ba? The mass mo na siya di matabo, di ba? Okay, so mass in grams over the mole. Okay? Ganun siya. Then, i-compute man imong mole. So, mole is equal to grams per molar mass. Molar mass is just equal to molecular weight or atomic weight. So, this is molecular weight. Okay, mo na siya. Ang may tabo. Okay? Now, okay man imong mole, no? Now, naman tayo area and velocity here. Unsaon man nato in which maka-obtain ta og mole per hour. So that it will become a molar flow rate. So we need to use this. Okay? Equation. Okay? Unsaon man nato siya pagkuha. So we need to calculate the grams. Okay? Grams, mole times molecular weight, or it could either be basta ganun siya, basta ang imong unit is kini siya. Kaya kasagaran mga good guys, hindi siya nimong memorize kay mole naman lang siya, kasagaran kanina siya mass flow rate, ang volumetric flow rate. So dapat gini i-memorize, no? Okay, sige lang tabo naman. Okay, so muna siya. Kani siya, di ba? So para mahibaw gud nimo unsay nga tabo nilang higayuna, so ari na lang kadari-ari. So kay grams, iparihan mo siya sa mass flow rate, granting lang siya bang mo ni tabo. Okay, so molar mass, molecular weight, okay, times mole, okay, mo ba ang grams? Yes, no. So molecular weight times mole, times area, times velocity. Okay, muna na yung molar flow rate, it's silang. Okay, atong i-prove later because I don't memorize the exact formula of a molar flow rate. What I understand is the volumetric flow rate and the mass flow rate only. Okay, so the mass flow rate is in terms of kilogram per hour. Okay, let's say the density of water is 1,000 kilogram per cubic meter. The area is in meters squared. Okay, like that. And the velocity is meter per second. So, ang mabili mo na ang higayuna, okay, m, makancel mo siya, okay, ganun siya, chupa-chuchu, charot. Okay, cancel. So, mahimo na siyang kilogram, ari. So, from cubic meter, hantod maabot siya sa, mahimo siyang mass flow rate, kilogram per second siya ang habilin. Si tanawa. Okay? Kilogram per second siya. Okay guys, cubic meter man, cubic meter cancel. So kilogram per second. Ano na yung mass flow rate? Ang volumetric flow rate guys, okay, tangtango na nimo ang density. Area times velocity na lang siya. So pila na may area? Kung naka-area na meter squared, times nga velocity nga meter per second. So it could be cubic meter per second, in which cubic meter is the unit of volume. So our volumetric flow rate is cubic meter per second. And you can convert that to gallons, gallons per hour, chupa-chucho. Basta mo hinumduman guys na 1 gallon is equals to 3.785 liters. So that we can convert this cubic meter per second into liter per second or gallon per second. Something like that. Muna siya yung value sa gallon. Okay? Again, 1 gallon is equals to 3.785 liter. Okay? Ganun siya. You get the point? And then 1 feet is equals to 0.3048 meter. And then 1 meter is equals to 3.28 feet. While I introduce this to you, because you can convert this also to cubic feet per second. Okay, like that. This one. So how can you convert a cubic meter to cubic feet per second? So you need to know the conversion factor from meter to feet, from feet to meter. That's why I say 1 feet is equals to 0.3048 meter. 1 meter is equals to 3.28 feet. So that if the problem have a given of cubic meter per second, it's easy for you to convert that in feet. Okay, or in cubic feet per second. Okay, but usually it will be expressed in cubic meter, cubic centimeter also, and in gallon, and in liter. Okay, now if I say guys nga kuan, pound per second, or pound per hour, ano siya ang usual nga unit? Pound per hour or pound per second. Now, it is not a volumetric flow rate, it is a mass flow rate, because pound is a mass. Okay? So, saan naman sa yung pag-convert yan ng higayuna? So, may ganyan ka nga, kuan, 454 grams is equals to 1 pound. Ganon. Get the point? May nga nga, kuan. So, 454 grams is equals to 1 pound. Ganon. So, 1 pound is equals to 2.2 kilograms. I'm not really that sure, guys, ha? Okay, so 454 grams is equals to 1 pound. Okay? Yeah. Na ako'y nahimunumduman, if it is correct or not, maybe I'm wrong. 1 pound is equals to 2.2 kilograms. So I need to prove this by converting pound to gram first and then gram to kilogram, just to prove that what I memorized 16 years ago is correct. Because maybe my memory fails. So what I memorized, 1 pound is equals to 2.2 kilogram. So just prove that to me, guys. Put that in my comment section kung maubagin niya siya ang value. E kapoy na kayo siya derive. Uy, sa'yo naman siya convert from pound to gram and gram to kilogram. I have no time to convert. So just tell me if this 1 pound is equals to 2.2 kilogram is correct. Okay, but what I understand, sure, 454 gram is equal to 1 pound. 454 grams. 101% correct talaga ako dyan. 454 grams equals to 1 pound based on my brain cells. But this 1 pound is equals to 2.2 kilogram, I'm not that really sure. Okay, that's what only registered to my brain cells. Okay, then just tell me if it is correct or not. Okay, that was 20 years ago. Okay, ganan. So, muna siya mahitabo. So, muna siya, guys. Ako ta i-prove ang molar flow rate, no? I-prove ba na ako ang molar flow rate? Oh, sige. So, na naman tayo area, meter squared, velocity, meter, okay, chuba-chuchu. Okay, muna siya may tabo na ng hikayuna. Then, molecular weight is grams per mole. Charot. Diba? Molecular weight, yes. Grams per mole, times mole, di kan ang mole. Diba? Correct? Yes, correct. Okay? So, kung makancel ang mole, dili siya molar flow rate, dapat mahabilin ang mole. O, ganan. So, ganun mga tirada di ara. Okay? So, it could either be, para di ka maglisod, okay, mag-start siya sa mass flow rate o sa volumetric flow rate. I-convert din mo siya sa molar flow rate. Ganun na lang. Okay? Naman kay molar mass o molecular weight relationship, dali na lang siya ba? Okay? Kung imo magbuhat-buhat yung kag-formula, mura maglibog ka. Nalibog gani ko karon. Okay? So, kung nakay palitan, nakay kuan, na cubic meter, kilogram per second. Ang kilogram per second, i-convert din mo into grams, di ba? 1,000, 1 kilogram, 1,000 gram. Ang kaning gram, di ba naman na siya ay gram, yung nasa kay molar mass, katong molar mass is equals to gram over mole. So mo na may tabuan na, imo na siya ikuan ana. I-multiply mo na siya sa reverse sa molecular weight. Dara. So, ang imong mass flow rate, i-multiply nimo siya sa reverse of your mass flow rate or divide by the mass flow rate. Mao na siya ang imong molar flow rate. Na kung dili po ka sa kuan, sa volumetric flow rate, dugay ka maabot dito. Dugay ka maabot kaya ang kanimong volumetric flow rate, wala man siya density sa iyang original equation. Ano naglagay mo? Ulo, man kasi dali nga maabot, di ba? Total, maabot, ma-solve magyapon nimo ang molar flow rate. Right? So, ano ka mag-start sa mass flow rate para makakuha ka og molar flow rate. Either i-multiply nimo ang reverse molecular weight or either divide directly to the molecular weight or the molar mass of a particular substance. Kaya mao na siya pero guys, mabalik-balik sa mga problem solving sa chemical engineering major questions kani mass flow rate, volumetric flow rate ug molar flow rate. Okay? Na yung mga RRs kasi sa denominator. Okay, mo na siya. Okay? Then pagkitaon na mo, how much time? Ito ko, gano'n. Sa inyo lang kayo, okay, na may time na ubos. I-multiply mo sa muli, makantil din, time ang mabilin. Pakapin na malanggon na siya. Okay, kanami yan. What time that this benzene will go there, blah, 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 so on, so na naman kay molar flow rate na may time sa ubos. Oh, di multiply din mo ka, yung molecular weight. Iba na ba na, iba bang i-multiply mo, bang i-divide, basta makancel ang unit, may mo siyang time. Ganon siya ang technique. Okay, ha? Okay. Para makuha ba, ma-legit. Charot! Charot lang ko eh. Legit. Diba? Mugin siya, mag-effort juga. Okay, grabe kayo. Grabe juga tinunanay guys, basta chemical engineering yun. Grabe juga kayo, guys, buhay. Okay? Tinunanay lang. Okay? So, usually, di ka makabanjing-banjing if you really want to become a registered chemical engineer. Di ka magpabanjing-banjing. Okay? Muna siya. Now, so kung kay inaani nga pressure is equals to density times velocity squared over 2 plus, charot ay? Nag-monitor ko sa time kasi kay basi gutumon ko niya. Char! So, G, H, density. Mano siya ng standard formula sa Bernoulli, no? Onya, magkuha ta para mahimo siyang pressure. So, natin itong higayuna. So, you will multiply this to, let's say, okay, 1 over density, right? Okay, 1 over density. So, it will become pressure over density plus V squared over 2. Okay, cancel man ang density. And the density GH na lang siya is equals to 0. Okay, wala siya. Okay, ang sunod, ang sa matunghaton ni higayuna. Okay, so, ato siyang multiplyan og kuan. 1 over density G. Ganun ba? Para makancel ang kuan. Okay. So, let's try 1 over density G na. Kani siyang second equation, guys. We multiply this whole quantity or expression to 1 over density. And the next, also, we need to multiply this to 1 over density over G para ang habilin pressure na lang siya in terms of pressure tanan. Okay, static pressure. And energy man na siya diara. Okay? Nakuha mo? Oh, so ingon ka nga 1 over density G na sa nang i-multiply ni ana. Okay. So mahimo na siyang pressure density G plus cancel ang density. So it could be velocity squared 2G okay plus H na lang siya. So man imong third equation. Okay, sa Bernoulli. So Bernoulli has 3 forms of equation nga magpili ra ka. Either in terms of pressure, in terms of energy, and in terms of the height itself. Ganun siya. Okay. Atong i-prove. Ano ka sa equation 2? Equation 1, equation 2, equation 3. Ang equation 1, na-prove naman nato nga nasa unit tanan nga kilogram meters kung ma-add siya tanan. Okay, but in equation 2, ma-add ba ni siya tanan? Atong i-prove. Okay, kung dili siya ma-add tanan, what we multiply this quantity is wrong. Okay? So let's do this. Okay, pressure numerator. Ay, makita do fairness. Oh, makita na ba? Chart. Oh, di ba? So pressure density. Oh, unsa man siya? This is ang pressure, nakakaloka. Tapos pressure is supposed to force over area. So it's gonna be Newton meter squared. Right? So, ang hirap. So, Newton meter squared over density over kilogram per cubic meter. Nakaloka? Okay, then ang Newton, i-convert pa gano'n mo siya in terms of ibungkag mo, mahimo na siya kilogram meter per second squared. Okay, then over meter squared over kilogram cubic meter. Uy, kapaghan. Okay, how can we do this? Okay, let's say, okay, makancel ang kilogram. Diretsahan, right? So, cancel kilogram. Tayo pa sa, okay. Ano imo siyang balihon, so mahimo siyang ganon. Meter squared, charat, wait. Ganon. Okay, okay, meter squared, and then, ganon siya, 1 over meter cube. Okay, 1 over meter cube. Meter cube over 1. Ganon siya. So, it's gonna be, cancel. So, meter, cancel ang saka meter here. So, it's gonna be meter per second squared. Sure ka? Meter per second. So, wala siya kuan. Wala siya in terms of seconds. Lisod man siya. Ano na sa kaduha? Lisod. Okay. Dito sa kaduha kayo. Surrender ko sa primero. Okay, so v squared over 2 lang sa tadirari. Okay. Gamera kayo ang magnetic board, oy. Okay, v squared over. Dali na siya, di ba kani? Mubalik na taan eh. I-complicated kayo ang pressure. Kibaw ko nga pressure Newton meter per square. Kibaw sa kumubungkag sa Newton. Pero nagkakuan-kuan. Balitok-balitok bitaw. Sa numerator, sa denominator. Dagan makay chuba-chuba-chucho. Kanina kong nahon. So, V squared. Okay, meter per second squared is equals to meter squared, second squared over 2. Sa'yo na kayo siya guys, di ba? Eh, moro ko na siya, oh. Diba? Inagakuan mo sa kuan, cancel gayon siya. Ganon. Diba? So, b squared over 2 na agad siya. Okay? So, muna siya imong habilin. So, ang imong kuan na niya is meter squared second squared. Kanimo sa GH. So, meter per second squared times meter. So, it will become meter squared second squared meter squared second squared. Pareho siya. So that could mean that the first expression also will be meter squared per second squared so that ma-add siyang tulo. Okay? So expected na ka nga meter squared second squared yun siya guys. Ha? O manimetabo. So ato i-prove again. So pressure Newton meter squared over density kilogram cubic meter. Newton kilogram meter per second squared, meter squared kilogram cubic meter. Cancel, kilogram, charanat. Okay, nakakaloka. So, like this. So, cancel mo sa M. Cancel. So, meter squared, second squared siya. So, ma-add na siya. Kini siya, meter squared over second squared, meter squared over second squared, meter squared over second squared. Sakto ni siya ng formula. Ay katulo, P over D, density G plus V squared over 2G plus H equals to 0. So, na nato siya. Ang technique lagi niya na guys, no? To prove that those quantities or those terms are really aligned with each other, take the unit of each. Okay, plasma na siya, it is understood to have the same unit. Okay, if not the same unit, then do not force that to use in your equation. So, meaning to say, that is not compatible. Okay, ana na lang siya. So, we have 3 equations in Bernoulli. Ano siya? Yung gamiton Fermi. So, static pressure plus dynamic pressure plus hydrostatic pressure. Okay, static energy plus dynamic energy or kinetic energy plus potential energy. Okay, or hydrostatic energy. The energy at stored energy. Okay, not yet at motion. And this one also, in terms of kung ano lang siya, elevation H. O, ato pa rin i-prove or din lang yun. Kay H, understood gini siya guys na meter na siya, kay meter na gunang H daan. Ng elevation. So, i-ensure yun nga, H gini siya ha, meter gini siya, meter gini siya. Try lang nato ang kaning, kuan, let's say, this second term, kaya murag sensayon siya. Okay, so meters per second, 2 times acceleration due to gravity, then with 81 meter per second squared. Okay, ganun, chuba-chucho. Meter squared, second squared, and then, meter second squared. Cancel. Yeah, meter siya. So if meter ang second term, meter ang third term nga H lang siya, it is expected that the unit of this one is also meter. Pressure divided by density times the acceleration due to gravity. Now, I don't have it to do that anymore, but sure kung sakto gina siya, okay? Kapoy na kayo derive ko okay. Diba? Kamu na lang guys, try to divide the pressure over pressure over the density times the acceleration due to gravity. It will have a unit of m. The same with the second term and the third term sa Bernoulli equation in terms of head. Okay, in terms of head or elevation or vertical distance. Okay, meter naman lang siya. Okay, ang third equation. Okay, any questions so far? Nothing? Charala. Okay, di ba klaro siya? Okay, okay na siguro ni siya. Kasabot na mo, sure. 100%. Charot. Okay. Muna si Metapo. Sa expression of concentrations, ayaw mo kadlo kay ang kanang normality, dili siya permi gamiton. Ang permi jud gamiton no, harun mo masayod, ang kana jud siyang molarity. Molarity or kanang in terms of moles per liter, capital M. Panagsara jud kinagamiton ang normality, ang capital N o ang molality sa higher chemical engineering subjects. Di ba natin mga, di ba? Molarity, capital N or molar, right? Ang unit kay moles per liter. So or N over the volume is equals to C. C is the concentration, right? Ganon. Naman sa tayo, capital N, muna siya gitawag og normal. Normal ang unit or normality. Lisad siya molarity, lisad normality. So ang normality, kikuan man na siya equivalent weight of solute, okay? Equivalent weight of solute over liter of solution. Ganon. Ang equivalent weight of solute mo, ito siyang guys, na katong, di ba, na mga OH, katong mga hydroxides compound, o katong mga NiH nga compound. Then, kung ganun siya, how many replaceable H during the reaction? For example, H2SO4. H2SO4. Di ba? Ika-react ni mo na dito sa sulfate. Di ba? Mapunin siya duha ka oxygen, ang ganun, chuba-chucho. So, ang kanang positive 2, mo na imong i-divide sa molecular weight anang sulfuric acid. Mo na imong equivalent weight of solute. Okay? Kung acid siya, nga imong i-prepare ba sa solution sa laboratory, kaya naman ito, 0.5 normal of sulfuric acid, 0.10 normal of, let's say, hydrochloric acid or permanganate, mga ganon. So, ang pasabot na niya, na-share ka ng H ba, pila ka buok ang chemical reaction. Kung base sa OH yung gamiton, sodium hydroxide, okay, potassium hydroxide. How many OH, replaceable OH ions ang imong i-divide niya sa iyang molecular weight? So, NaOH divided by 2. Ganan. KOAH divided by 3. Kung 3 ka ions replaceable during the chemical reaction. The same with the acid. Mo na siya ang normality. Equivalent weight of solute over liter of solution. Na kanin siya, dili na siya pirmi gamiton sa higher chemical engineering science, ato kag physical chemistry, unit operations, okay, mga ganon, transport phenomena. Ang kasagaran, ari na dyan siya kutob sa molarity nga moles per liter. Even sa thermodynamics, di siya maabot aning normality chuba-chucho. Ang kanang normality chuba-chucho, kasagaran na siya ma-apply sa physics o sa chemistry. Di ara siya kutob sa quantitative, qualitative, ganan. Chemistry ba? Ay, kahadlok, di na siya maabot rin. Kay gubot man guni siya, gubot. Mo siguro din nila pirmi unit dito kay gubot siya, di ba? Equivalent weight of solute over liter of solution. Lisod na jud kaay na siya, di ba? Kay nala mga replaceable sa chemical reaction, ganon, di ba? So, napadjud usa guys kanang molality na small letter M, molal. Kani siya posible pa ni siya ang molal. Adto ni siya mo gawas sa Henry's law o sa Henry's law o sa Rayleigh law. Okay? Sa physical chemistry nga topic nga Reel's law of gases and the Henry's law of gases. Kaya sometimes guys dito ang solubility in terms of molal. Okay? But kasagaran po noon molar, pero naadyo yung sagol nga molal sometimes. Okay? Imo siyang nanaon nga, that is kilogram of solute. Okay? Kilogram of solute over the of water. Kilogram of water. Ganan. Sorry. Di na siya kilogram of solute. Moles of solute, sorry. Moles of solute over kilogram of water or solvent or any solvent na imong gi-refer dito sa imong aqueous solution. So, muna imong molarity. So, molarity, small letter M, molality is equal to the moles of solute divided by the kilogram of solvent. So, since in most cases, water siya, manang niingon rin nga, kilogram of water. Pero dili na sa tanang higayon water good siya. Common lang yun ang water. Muna yun siya nga, moles of solute divided by kilogram of water. Ganun. So, muna yung timanan sa mga expression of concentration or the solubility. Okay, muna siyang molarity, normality, and molality. Molar, normal, or molal. Capital N, small letter n. Muna siya. And I thank you. Ganun. So, ipasok niyo sa inyong brain cells, pero medyo na magbalik-balik eh. Nasa yung mga kung ano, N1, V1 is equals to N2, V2 ka lang. Pagkitaon sa mo mga concentration sa ikaduha, sa ikatulo. Mura sad siya katong equivalent sa katong kuan ba, steady state. Mag-apply po ka ani niya as expression of concentration. Concentration in 1, solution 1 is equals to concentration in solution 2. Gi-assume man sa niya nga, achieve siya of law of conservation of matter. Diba? Kay substance naman ang itong isgotan ni ini, mga concentration. Okay. Up mo na ningon ko nga na ay law of conservation of mass, law of conservation of energy, law of conservation of matter. Kailang makasabot ka ni ining mga lolos, chuba chucho. Kaya ma-apply man ni ini. So, solution 1 is equals to solution 2. Mixture 1 is equals to mixture 2. Ang imong solution 1 will be equal to N1, V1 is equals to N2, V2. Or molality 1, molality 2, ganon. Okay, molality 1, molality 2. Okay, ganon, chupa-chucho, di ba? Okay. So, kaya kana imong concentration, mo man yung formula, i-follow lang jud ani mo diri isud nimo sa iyang 0.1, 0.2, 0.2. For example, molality. Okay, molality 1 is equals to molality 2. Sa may formula sa molality diri ari, di ba? Ingon ka nga moles of solute over kilogram solute. Sa butang diri so, mole of solute 1 over kilogram solute 1 is equals to mole of solute 2 kilogram solute 2. Bingo, makuha nimo ang mga wala gihatag nga quantity. Mo na technique diha sa mga solution expression of concentration in which sa day 2 na siya siguro or sa day 3. Physical and chemical principles examination. Okay? So, di na siya limited sa molality ha. Molarity sad siya, normality sad siya, kana yun tulo. Muna ilain. Okay? Muna gan emong kalibog guys, kung naga na siya i-given nga grams per liter, sometimes, di ba? Nilubog na siya. Kanang grams per liter guys, it's not a solubility, it's a density. Okay? Kaya imong hinumduman ang density, mass over volume baya siya. Pero sometimes mo gusto question, naingana ba nga, marag, gitso lagi ni niya. Actually, that is a density, not a solubility. Okay? Naitang inyo ni anak. Labi na sa koan, sa extraction. Kabantay mo sa extraction process. Dimin ka nga. Weight of solute, raffinate. The weight of the solute in the raffinate. Yung gano'n, di ba? Over of the weight of the solution in the raffinate. Yung gano'n. So, usay magunam ko na volume diha ara. Kay volume na kasagaran ng extraction, di ba? So, maglibog din ko lang. Di man na siya volume, mas man na siya, uy. Kung imong ibutang baya ang grams sa taas, grams na ubos volume, grams per liter baya siya, dili baya siya solubility. Okay, ganon. And then, imo sa hinumduman nga, with fraction ng gisgutan di ara, uy nga lagi ang ubos, volume man siya. So, dili na ba? O, ana ba, imong hununaon. Okay, kinatoy nakita nga vlog, nasayop siya. Okay, a Filipino vlogger na engineer po siya, pero irang gid so bright ka siya math, okay? And then he compute. Mao kaya po ang answer good. The same answer but the way he expressed the unit in his calculation is wrong. Kaya magibutang ang volume ang kuan, ang weight fraction over the weight fraction of solute. Weight of solute over the weight of the solution mo na siya ang weight fraction of the raffinate, di ba? weight fraction of the extract also mura sa gyapon, di ba? Mass of the solute over the mass of the solution na yan gibutang og 100 liter. Kay ikakuan dito mao ra man gyapon kay nganong mao ra gyapon kay ang density sa water 1 ra baya siya. Ika multiply nimo 100 mahimo man na siya 100 gram. So dili mo matter kung water. You get the point? Now, kung dili na siya water guys, it will never holds through. For example, benzene, toluene, ganun kadili man na siya density sa benzene dili baya 1. So you could not say 100 gram of benzene mausad siya 100 gram liter of it. It's not because it's not density equal. Di man siya 1 ang density sa benzene at certain temperature. Nagkataon lang dito siya nga water nga at standard assume pirmi nga 1 gram per 1 kilogram per liter per mi ang density or 1 gram per ml. What if kung dili na siya 1, okay? Kaya dili na siya water, mo itong nasakto siya dito, okay? Pero actually wrong ang iyang kuan, ang iyang. Pero may kaya siya mo compute. Right kaya siya ba? Pero ito na siya nakatalunan sa theory. Okay? Theory ba? Theory aspect. Iyara yung giditso-ditso. Ang alam ko ng mga bright kayo, giditso-ditso naman ganun nila kayo makasabot. Paspas na kanilang brain cells ba? Pero usahay man God, ma-miss nila ba ang kuan gitong silang pagka-bright. Ganon. Okay? Masayo pa mga tangarita bright katubag sila masayo pa sila panagisa, di ba? Ganon. Na wala ra ba ni correct? Wa ko ni correct bahala ko diha. Ako lagi pasagdaan. Okay? Ganon. Kaya may mga a lot of chemical engineers vloggers also in YouTube. Ako itong gitanaw siya. He's a Filipino. Okay? My gosh. I forgot the school also. I think, sa ba to eh? Adamson ba to siya? Adamson University or something like, basta nakalimot ko sa university. Okay, di siya sa Cebu, sa, siya, sa Luzon. Okay? My gosh. Okay, thank you so much guys for watching this live streaming and vlogging. I hope you learn a little bit of my discussion. Thank you so much. You can comment down below in the comment section and you can subscribe my YT channel if you want to also. And then you can click the notification bell for some news updates of I Am a Singer, Eternal Voice. Bye bye. God bless everybody. Wow. Charot. Okay, diba?